All right, we are looking at 8.38. Just kidding. We are looking at 3.2 notes. It says write an equation that models exponential growth or decay. So I'm going to, we already talked about 1 through 5 in class. We still need 6 through 10 to look at to complete our notes. And then you should be able to finish everything in your homework. So starting with number 1, it says a laptop computer was purchased for $1,400 each year since the resale value has decreased by 26%. Let T be the number of years since the purchase. Let Y be the resale value of the laptop computer in dollars. Write an exponential function showing the relationship between Y and T. All right, so we've already discussed this before, the difference between exponential growth and the difference between exponential decay. In this case, what is it going to be? You guessed it right. It is decay. And the reason why we know it's decay because it says it decreases. So if my equation is Y equals, in this case, A times 1 minus R, because it's decay, it's decreasing, I'm going to use the subtraction sign. Let's go ahead and identify what A is and what R is so we can write our equation. So A in this case is 1400. Your R is 26%, but we need to change that to a decimal. So if I change percent to a decimal, we do Dr. Pepper. So I want to go from percent to decimal. So from P to D, I go 2 places to the left. So 1, 2. So 0.26. So your equation is Y equals A, which is 14,000, times 1 minus R. Oh, what's R? 0.26 to the power of T. Well, what is 1 minus 0.26? This is your final answer. Moving on to number 2. So solving a multi-step equation involving a single logarithm. So what we're going to do is change this to our exponent, okay? So we get log 3 times 4x minus 2 equals 4. So we are going to change that log to now an exponent. So when I do that, that becomes 4x minus 2 equals 3 to the power of 4. I took the base of that log, made it the base of this exponent, and I shot that exponent up to 4. All right, so then we're just going to solve this like regular. 4x minus 2 equals 3 to the power of 4 is 81, because that's like saying 3 times 3 times 3 times 3. I'm just going to solve it. I want x by itself, so I'm just going to continue on. I still need x by itself, so that means I need to divide by 4. 83 over 4 does not simplify, so I'm going to leave it as is. We're going to move on to number 3. Number 3 is pretty heavy, so I'm going to add another sheet here somewhere. Add another sheet, and I'm going to look at number 3 on this next page. All right, so they give us log 5 times x plus 3 equals 1 minus log 5 times x plus 7. They said solve for x, so they want us to get x by itself. So I have log 5 times x plus 3 equals 1 minus log 5 times x plus 7. All right, so what you're going to do, we're trying to get x by itself. So what you're going to do is first move that log 5 times x plus 7 over to the left side. So right now it's negative. In order to move it to the left side, I am going to add it. Whatever you do to one side, you must do to the other side. This was that long question that we did in class the other day. Okay. Equals 1. Now, I can combine what you like to call like terms. I notice there's both a log 5 here, so I'm going to call this log 5 times x plus 3 times x plus 7 because they're both multiplying. I'm just going to go over to the side and go ahead and multiply what's inside that parentheses. I showed you how to do this in class, so you should be familiar with how to multiply polynomials. That ends up getting me x squared plus 10x plus 21, because these are the only like terms that can combine together. I get log 5 x squared plus 10x plus 21 equals 1. Okay, so similar like what we did on the other page. I notice equals 1, sorry. I notice we have a log 5, so I can take that 5 base is going to be my base and my exponent of 1. X squared plus 10x plus 21 equals 5 to the power of 1, which is just the same as just saying 5. I noticed something. This looks similar to that one thing we like to do. So I see that we have a quadratic going on here, which means I have to have this to equal 0. So that's why you notice I moved that 5 over, so now that it can equal 0. Okay, we're going to do our ABC method. A times C is 16, B is 10. Pause the video, take a moment, find out what two numbers are going to multiply to get you 16, also add to get you 10. Assuming that you paused the video, you should have gotten 8 and 2. After that, we bring everything down. You know this. You can probably do this in your sleep because we do it so much now. We can group these together. I'm left with x and x plus 8 inside the parentheses, with 2 on the outside and x plus 8 inside the parentheses. I have x plus 8 and x plus 2. But we need to see if these, this is negative 8. We need to see if these are a true statement, okay? So I'm going to take these and put it into the equation and see if it's true. So we had x equals, let me add another page. All right, we had x equals negative 8 and x equals negative 2. All right, so everywhere I see an x, I'm gonna put in for negative 8 plus 3 equals 1 minus log 5. We did this in class. We're just looking at it again. You should be able to simplify this, and then you're going to put this in Desmos to see if it's true. When you put it in Desmos, you probably notice that the first one set undefined. So that means negative 8 won't work. Let's go on to negative 2. Log 5, negative 2 plus 3 equals 1 minus log 5, negative 2 plus 7. When I simplify that, it's going to give me log 5, 1 equals 1 minus log 5, 5. When you get that in Desmos, you get 0 equals 0. So that's why negative 2 is your answer.